Welcome to TS classes. This is my fourth video of control system. In the last video, I have studied you the mechanical model of control system. In this video, I am going to study about the mechanical system, conversion of mechanical system into electrical system. Okay, in the last class we have studied there are two types of mechanical system. One is translational system, another is rotational system. In this class, I will tell you about the conversion of these two systems into electrical systems. Okay, for this I have in translation system there are two process. One is the force voltage analysis and second one is the force current analysis. Similarly, for the rotational system there are two types of conversion system. One is the torque voltage analysis, another is the torque current analysis. I will elaborate all these four parts one by one. First we will study about the force voltage analysis, which is the first model of the translational system. Here the mechanical system is converted to electrical system. Here in the mechanical system one input is here and output is also present, and also in the electrical system input and output also present, and the input of the mechanical system is force and input of the electrical system is voltage source. So from the force to the voltage source conversion is known as force voltage analysis. Here also output is there, output is voltage. Electrical system the output is current across. We have already read that in mechanical system there are three types of forces. One is force due to mass, second force due to dashpot, and third is force due to spring. First we have studied f of m is equal to m into d square x by dt square, which is the force due to mass, which we have already read in the last class. And here the output is velocity. It means we have to calculate here the velocity part. We know that velocity and here x is displacement. The displacement and velocity relation is dx by dt is equal to v. Dx by dt is equal to v. If you put this part in the equation, we can get f of m is equal to m into dv by dt. F is equal to m into dv by dt. Its diagram will be like this. Mass F acting in this direction and f of m in opposite direction. This is the mechanical system. If I convert this mechanical system in electrical system, I can get the input is a voltage source. That means a voltage source is present here and an inductor is there. In the output side the element is inductor. Okay, here the equation will be V is equal to L into di by dt. Here we have written f of m is equal to m into dv by dt, and in the electrical system the voltage V is equal to L into di by dt. These two are two similar equations. That means here the mass which is converted into the inductor part, force is converted to voltage, which is the force voltage analysis, mass is converted into inductor, and velocity is converted into current flow. And velocity here the output was velocity, and in electrical system the output was current. This is the only fast part for when mass is given. Okay, this is the force due to mass f of m, and also there are two other parts. One is the force due to dashpot and one is the force due to spring. Okay, let's study about what is the force due to dashpot. The force due to dashpot, that is f of b is equal to b into dx by dt. That implies f of b is equal to b into v, because velocity is your output, f of b is the input force, f of b is equal to b into v. If this force due to dashpot is converted into electrical system, we can get it that input is the voltage source and output there is a resistor is connected. Resistor is connected, input here is the voltage and current across is I. So here V is equal to I into R. V is equal to I into R. Here f of V is equal to B into V. So force is converted into voltage and velocity is converted into current, and the B, that is the frictional part, is converted into the resistance part. Okay, this is the force due to dashpot. And one more thing is there, that is the voltage due to, force due to spring. we know that the force due to spring F of k is equal to k of x. We know that F of k is equal to k into x. If x is converted into velocity, we can get k into integration of v dt, because displacement and velocity, the relation is x is equal to integration of v dt. Okay, if I convert this part into electrical system, then we can get the voltage input is here and output side a capacitor is connected. Output side a capacitor is connected, and here the formula of voltage is equal to 1 by c integration of I dt. 1 by c integration of I dt. Here the force is converted into voltage, the output velocity is converted into output current, and the constant here is k is converted into capacitance part. These three are the equations of the force voltage analysis in mechanical system. Now we will study about the force current analysis of electrical system. Now we will study the force current analysis of the translational system. Here one difference is there. That is, in the mechanical system the input and output is same. But in electrical system the input and output are interchanged. That means the input is the current source and output is the voltage across the element. Okay, input is the current source and output is the voltage across the element. It is also three types: the force due to mass, force due to dashpot, and force due to spring. First we will study what is the force due to mass. If the force due to mass F of m, we know that F of m is equal to mass into acceleration, that is equal to m into d square x by dt square. But we require output is the velocity, that means F of m is equal to m into dv by dt. This equation is required for the conversion of mechanical system to electrical system. Okay, in electrical system what is happening here? Input is the current source and output is the voltage. That means input is the current source is here and output is voltage. Here the voltage is across the capacitor element. The element is here is the capacitor. Okay, that means here current I is equal to C into integration of V dt. Force due to dashpot, that we have already studied in the previous in force voltage analysis. The force due to dashpot was B into V and force due to spring was K into integration of V dt. Now we will convert these two equations into electrical system. If we convert the force due to dashpot in the mechanical system into the electrical system, then the F of V will be converted into output current. So input was the current source and output was the voltage across the element. Here the element is resistor. So input is current source and output place a resistor is connected here. I, here R is here. So we know that I is equal to V into 1 by R. That means I is equal to V by R. Here the equation was B into V. Now the equation is I is equal to V by R. Here the force due to dashpot F of V is converted into current, and the velocity output was converted into output voltage. V is converted into voltage V, and the fraction dashpot B was converted into 1 by R resistor. Clear? Now the last part is that is the force due to spring. We know that the equation of a spring, equation of the force due to spring is F of k is equal to k into integration of v dt. In the here the output side a inductor is connected. The input is the current source and output is the voltage across the inductor. So the equation will be I is equal to 1 by L into integration of v dt. 1 by L into integration of v dt. That means here the F of k, which is the force due to spring constant k, is converted into the current source. The force is converted into current source and output velocity is converted into output voltage. That means F of k is converted into I, V is converted into voltage V, and K, the spring constant, is converted into 1 by L. Here we have completed the three transformations from the mechanical system to electrical systems. That is the force due to mass, friction and spring constant. Okay. Now the translational system is over. In the next class we will study about the rotational system. Thank you.